Hello, my favorite algebra students. Welcome back. We're going to talk today about lesson 33, products of prime factors and statements about unequal quantities. If you're in my class, you need to be taking notes on these in your notes section or video section, if you call it that. We're going to talk first about this. Example number 1, prime factors. Express 80 as a product of prime factors. So what we're doing is we're doing prime factorization, and just a friendly reminder, prime numbers are numbers that you can only multiply by itself and 1, right? So our most common prime factors, if we were to go in order, 1 is not actually prime, but just keep that in mind. 2, 3, not 4, but 5, not 6. 2 is the only even number that's prime because every even number after that is divisible by 2. So 5, so not 6, so 7, 9, no. 11, yes. 13, right? 15, no. 17, so like that, so on and so forth, right? So what we're going to do is we're going to break these numbers down into prime numbers. That means like this guy. There's a number of different ways that I could do this, but what I want to do is pick two numbers that multiply together give me 80. I love it when there's a 0 on the end because you could just do 8 and 10, right? Now, neither of these are prime, so I got to keep breaking them down until I get prime numbers. 2 and 4. Well, 2 is prime, but 4 is not. So, and as I get prime numbers, you see that I'm circling them, right? So 2 and 5. So writing it as a product of prime numbers means 80 equals, now there's 1, 2, 3, 4 2s. So it's 2 to the 4th power times, and you always want to go in order. There's no 3s here, but there is a 5. So 2 to the 4th times 5. That's all you got to do for these guys. All right, example number 2. Statements about unequal quantities. All right, twice the number is 42 less than negative 102. Find the number. So twice a number, right, and we're going to use n or any variable, I don't care, to represent the number, is 42 less than, so the word is, remember, is equals. Is this 42 less than negative 102? But I want you to remember the words less than mean that you have to flip these things around. This and this need to be flipped. So it's really 2n equals negative 102 minus 42. That's really important. When you see less than, flip it. It's not meant to be done in order. So it's not this. Good, and so then now we just have to solve this. We want to combine like terms before we go moving things left and right, right? So we get 2n equals negative 144, negative 144. Divide this both by 2. So we end up with 72, right? I have to think about that. Yes, n equals negative 72. Making sure I've got that right. Okay, so that would be your answer, right? So just remember the key thing is if you see the words less than, it needs to be flipped around. So let's try example number 3. That was example number 3. This is example 4. I skipped another prime one, so we'll have to do that. Okay, so 5 times a number, and if you're following along at home, this is page 135, might help so that you're reading them out. 5 times a number is, so 5 times a number is 72 greater than the opposite of the number. So greater than, again, means adding them together, and the opposite of a number just means making it a negative n. So negative n, right? Good, so now we have to solve this equation. We're gonna move this n over to the other side, and to do that we do the inverse, so we're gonna add it, right? Because then these go away, but what I do to one side I must do over here, okay? So this is now 6n equals 72, okay? To get that n by itself, I'm going to divide by 6, n equals 12, I believe. 6 times 12. I don't know my 12s, sorry. Yep, 72. Phew, making sure. So n equals 12. So this is how you need to be showing your work on these types of problems, okay? All right, example number 5. If the sum of twice a number and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number, find the number. Let's start that one by one. If the sum of twice a number, and remember sum means add, and negative 14. So if the sum of twice a number and negative 14 is multiplied by 2. If we take all this garbage and we multiply it by 2. So notice I'm using parentheses. If I had done times 2, that would have made my order of operations all out of whack. So you gotta be careful there. The result is 12 greater than the opposite of the number. So negative n. Find the number. All right, so we're gonna take this 2 and we're gonna distribute it to get 4n plus negative 28 equals 12 plus negative n. And remember there's like a 1 in front of this n here, right? So I want to take this n and move it over to here. I'm going to do the opposite by adding it. But what I do to one side of the equation, I must do to the other side. So plus n. Draw my line, cancel these guys out. I now have 4n plus 1 more n is 5n plus negative 28 equals 12. All right, the opposite of negative 28 is positive 28. So I'm going to add 28 to both sides. These guys cancel out, and this is exactly how you need to be showing your work. 5n equals, that's 0, carry the 1, that's 40. 5n is 40. Divide both sides by 5, n equals 8. N equals 8. So just knowing that the opposite of a number is just negative n, right? Knowing that less than means you have to do it, you have to switch the order around. And then knowing the word is means equals. Knowing that you may be using parentheses, that's a big one. Okay, so let's see about number 6, example number 6. 5 times a number is 21 less than the opposite of the number. What is the number? 5 times a number is 21 less than. Is 21 less than. I can't do that. Absolutely not. 21 minus 5n because it's less than, so it has to be flipped around, right? Is 21 less than twice the opposite of the number. Is twice the opposite of the number. All right, let's rewrite this so that it's a little bit more organized. 21 minus 5n equals negative 2n, because I combined these two things, right? I'm going to move my n's over to this side now because it's already there and I don't want to leave that as a 0. So I'm going to add 5n to both sides. Because if I do that, these guys go away. And now I have 21 equals 3n. 21 equals 3n. Divide both sides by 3. 7 equals n. Bam, your number is 7. Okay, so let's see. Minus 21. Actually, I think I did that problem wrong. Oh, I missed the word is. You guys, I did this one wrong. We're gonna have to do it again. Sorry. It's 5 times a number is 21 less than twice the opposite of the number. Twice the opposite of the number we determined was negative 2n, right? Twice the opposite, less than. So it's 21 less than this, but I have to flip it around because it's the words less than. So sorry about that. So in this case, why don't we add 2 to both sides? When we do that, we end up with, cancel this, we get 7n equals negative 21, okay? Divide by n, divide by 7 to get that n by itself. We get negative 3. So sorry about that, guys. Okay, so that word is very important, it turns out. All right, guys, so what I want you to do is the practice problems are on page 136, A through D at the bottom. Go ahead and do those and then come on back to make sure you got them right. Find a number such that 8 times the number is 36 greater than the opposite of the number. Okay, so 8 times the number is 36 greater than the opposite of the number. All right, so that's how we're going to set that one up. Add n to both sides. These guys cancel out, and I'm left with 9n equals 36. Divide both by 9, divide by 9, n equals 4. N equals 4. Good. Let's look at B. If the sum of a number and 6 is multiplied by 2, the result is 10 greater than the number. Okay, so if the sum of a number and 6, sum meaning addition, if all of that is multiplied by 2, the result is 10 greater than the number. 10 greater than the number. So this ends up with 2n. Again, that was really important. We use our parentheses there. Plus 12 equals 10 plus n. Minus n from both sides. This cancels out. I'm left with 1n, or just n, right? Plus 12 equals 10. Let me go ahead and move that 12 over by doing the opposite. Minus 12 minus 12. These cancel out. N equals negative 2. N equals negative 2. All right, 2 more problems, then you're good to go. C. Write the following numbers as products of prime factorization. 108. Guys, there's a trick for 3s and 9s. If you add 1 plus 0 plus 8, you get 9. Does 3 go into 9? Yes, 3 is going to go into this number. But also, does 9 go into 9? Yes, then the 9 is going to go into this number. So if we divide this, we get 108 divided by 9. I think that's 12. Yeah, 12 and 9, right? These are not prime numbers. This is 3 and 4. 3 is prime, so I'm going to circle it. 4 is 2 and 2. 9 is 3 and 3. So the product of prime numbers is 1, 2, there's 2 2's, times 3 to the 1, 2, 3, third place. That is the product of prime numbers right there. All right, D is going to be, where is it? Oh, 400. 400. So that's going to be 40 times 10, right? 40, that's 4 times 10, right? This is 2 and 2. This is 2 and 5. This is 2 and 5. All those prime numbers there. How many 2's do I have? 1, 2, 3, 4 2's times. How many 5's do I have? I've got 2 there. So 5 squared. There's your answer. All right, guys, excellent work. If you have any questions, let me know. Otherwise, I will see you in class. Thank you.